Alrighty folks, we are here today looking at section 2.2, which is on surface area. And just so you know, you don't need to memorize any of these formulas. They're all given to you in the data booklet. So have a look at those so you get to sort of see what you will be given. You will, however, need to know how to manipulate them because we don't often just calculate the surface area of a shape or object. Well, usually, like, there's a hole in it or there's a piece missing. So you kind of have to be aware of what each of those pieces of the formula mean. For example, if you take a cylinder that has a radius r and a height h, there they are there, then the surface area of the whole cylinder is expressed with this formula here, 2 pi r squared plus 2 pi r h. And the different parts of that equation relate to the different parts of a cylinder. Let's take the cylinder and let's sort of cut it along this line here at the front and then open it up into a flat two-dimensional shape. It would look something like this. Okay, you'd have this is the sort of the top there of the lid. Here's the top here, and then the bottom's over there. Okay, and then this rectangular piece is the lateral area that's been kind of cut open and flattened into a rectangle. And so I have two circles, and so that's where this comes from. There's 2 pi r squared. Pi r squared is the area of one circle, times 2 is 2 pi r squared, which means this must be the area of the rectangular part there. This is just a rectangle with a length and a width, okay? But the width is equal to the height. You'll notice this here is that height, and the length is the distance around this circle. In other words, the circumference, and the circumference is given by 2 pi r. And so the length times the width, 2 pi r times h. In other words, 2 pi r h. So all of those surface area and volume, well, surface area formulas, you can break them down that way, and I would encourage you to kind of do that where you can. But I won't focus on that during this lesson a whole lot, but just so you know, that kind of stuff, we kind of discussed it last year in grade 9 already. We haven't really looked at a cone before, I don't think, but the surface area of a cone, again, this is given to you, pi r squared plus pi r s. We know the pi r squared is going to be that circle on the bottom here. This here is the pi r squared. So the pi r s refers to the rest of that shape, which is, again, a lateral area. If you cut along this line here, and we've made cones before, maybe in younger grades, then if you flatten that out, it looks something like this. Okay, that looks a little weird, I realize, but it's just basically a portion of a circle which makes up the lateral area, and then the base is just a circle. Okay, and then the distance from here to here is just equal to the circumference of my circle. Okay, so that's basically how that works. The S, though, is something different. This is called the slant height and refers to the distance from the tip to the base along the slanted edge, not the vertical height. Okay, so that's something to keep in mind as well. So just to give you an idea then, let's look at one quick problem. So if I have a cone with a radius of 1 and a slant height of 4, well, just really quickly plug in those numbers and leave pi just as pi. Don't calculate it out. So your answer is going to be something pi. And see if you can figure out the same thing that I'm going to show you in 3 seconds. Okay, so it's pi times r squared. R is just 1. So that's just 1 times pi, which is simply pi. And then times, or plus, pi times 1 times 4, which is 4 pi. And so I can combine these. If you sort of treat pi like an x, for example, x plus 4x, then you get your answer 5x. In this case, it's 5 pi. That's your surface area, 5 pi centimeters squared. You could work it out as a decimal and get roughly 15 or 16 or whatever it would be. But this is an exact number. There's no rounding, so we like that better. You'll see that a lot, so I'm just trying to get you used to it. Okay, well, I want to show you something different, though, a different kind of problem with a cone, and I'll see if you can figure out how to do it. So have a look at this one. Okay, I have a slightly different cone here. The radius is 3 centimeters. The height of the cone from the center of the circle down here at the bottom to the vertex is 4 centimeters. So now you have to figure out the surface area. Why don't you pause the video again? I'll give you the answer in 3 seconds. Okay, so it's pi times r squared, radius is just 3, plus pi times the radius, which is again 3, times the slant height, which I don't have. So you have to work out the slant height first. You're going to do that using Pythagoras' theorem. Okay, so 3 squared plus 4 squared equals 5, or equals the hypotenuse squared. And in this case, it's the slant height, so I'm giving it the term s squared. So working that out, you get 25 because 3 squared is 9 plus 4 squared, which is 16, equals 25. So 25 equals s squared, so therefore the slant height is 5. I gave a nice easy one there for you. Okay, and we continue on with our problem, leaving pi as it is. So you get 9 pi plus 15 pi, and just add those two together, and you get 24 pi centimeters squared. Again, you could work it out as a decimal, but my answer is better. Okay, so just so we're not watching one huge big long video, I'm going to stop the video here for this one, and then the next video, I'm going to get you to try another couple of examples, give you one for homework, and then we'll call it a day. So, next video.